All right, guys. We left off in example 3 in class. We filled out this graph, right? We said if capital F of x is equal to the antiderivative or the integral of f of t, and we wanted to evaluate capital F of x at different values, it would just be the accumulation of the areas, right? And we got those values on the table. So we did that, and then you guys answered questions A through I, and it was just talking about where's the zero of capital F, what is the total change, what's the maximum value, and where does it occur, and so forth, right? What's the range? Now, we're gonna go back to the again to the initial question of what would happen geometrically if we allowed k, the lower bound, to take on different values, right? So that was for that function. Now, let's say we have this function here, okay? Capital G of x, and is the antiderivative of the function, and it starts at 3. Instead of 0, it's going to start at 3. So we look at this graph. If we start at 3, what would the area, if we added all the area, what would happen to it, right? And if you kind of see already that if we start at 3, okay, and we go to 3, we're going to get 0, right? Because you're not really going anywhere, right? If the upper and lower bound are the same, we're going to get 0. We'll talk about that a little bit later too. Because you would just have kind of like this little rectangle like that, right? Which with no area. And I think that came up in the example we had. But what if they ask you to do capital G of 0? Well, that means that you would have to take the derivative, the integral from 3 to 0. Now, we normally add the area as we go to the right? We accumulate the area this way. So what happens when they're asking you to go backwards? So all you're going to do is you're just going to subtract, okay? And one of the properties that we have for integrals is going to be that if you flip the bounds, it's just going to be the negative of that integral, okay? Now, do we know what the integral from 0 to 3 of f of t is? We already solved it. It was 4.5. So for this function, it's just going to be negative 4.5, right? Because it's the same. And that would answer our question. Now, just to make this a little quicker, what ends up happening is if we plot g of x, we would start at negative 4.5, right? And then it's going to be the same as capital F, but everything's just going to be translated 4.5 units down. So to answer the question, where is the 0 of capital G? Well, we just look at our function, right? If everything's translated down, that blue line would just be translated down 4.5 units, and we're going to have something like this. And we notice, though, that something occurs at 3, right? F of 3 is 4.5, so G of 3 is going to be 0, because everything's just going to be translated 4.5 units down, okay? And if I do that to like the main points, you guys will see that if I graph this function, it's going to look like this, okay? So again, let's examine what happens geometrically to the antiderivative and when we change the bounds. And all you're going to do is you're just going to get this vertical shift. Sometimes it'll go up, it might go down, just depending on where you're going, right? But the key thing to get here or to kind of consider is if your lower bound is greater than your upper bound, then you're going to get a negative value, or you should interpret as a negative value because you're getting the area from right to left, where we normally go from left to right. Okay, so just real quick, if we're moving this way, you're adding. If you're getting the area but you started from the right and you're going to left, you subtract the area. Okay, and that explains why that's going to be negative 4.5. So now that you guys have the graph, where is the 0? Well, it's going to occur at 3. What is the domain? The domain remains the same. If you look at the green function, it still goes from 0 to 10, still defined there. Okay, and then what is going to be the total change in G? Well, you started at negative 4, so the point they're trying to say that it's not going to be vertically stretched. Okay, it's just going to be translated or shifted down. So everything else remains the same as your f function. So what is the maximum? The maximum is not 12 anymore. It's shifted down 4.5 units, but it still occurs in the same x value, right? And then the range is going to be a little bit just shifted as well, okay, by 4.5. And we already sketched the graph, already showed it to you guys. That's what it's going to look like. Now, to answer more of these questions from the graph, describe the relationship between all antiderivatives as k takes on different values. Well, you're just going to say that all capital F of x are vertical shifts, okay? Again, you're going to keep the same function. They're just going to be moved up or down, okay? And then what point must lie on the graph of any of the family members? So if you were to look at all the different, right, f of x's that we could get with different k values, right? Make that negative 3, negative 2, 1, 3. We already did 3, 4, 5, whatever. They're just going to be shifted. And one thing that's going to remain the same is that the 0 value would start at that bound, at the lower bound, okay? That's what we're saying. And when you think about it, right, like what kind of rectangle would you get if you're going from k to k? I think that's kind of how I think about it. So as k takes on different values, the function capital F of x, graphs are all going to be what? They're all going to be vertical transformations, right? They're all going to graph as vertical transformations of each other, okay? And again, to summarize, each containing the particular point k0, where that lower bound would be where the graph is going to be equal to 0. And then even though the lower bound changed, the derivative of capital F is still equal to f of t? Yes, because we said that the integral is the antiderivative. So if you take the derivative of that, it would undo itself, okay? All right, that's for example 4.